In this video, we will be looking at the normal distributions and central limit theorem tool in Google Sheets to help us solve a problem. And we will be, in this video, looking at the probability calculations portion of this tool. So let's get started. Okay, so with the normal distribution and central limit theorem tool, under the probability calculations, we see that there's three different tools that we have here. We have when we're measuring the area to the left, the area to the right, and the area in between two values based on the shaded portions. And notice up here, it says in the very beginning, enter data in the green cells only. So your solutions will be in the yellow cells. And so let's look at the example problem here. We're given that the weights for newborn babies is approximately normally distributed with the mean of 6.3 and a standard deviation of 1.5 pounds. So we want to know if we have a group of 1,200 newborn babies, how many would we expect to be between 3 and 8? So between, we're given between for this one. So out of these three tools, that if we wanted to find something involving the probability, then we would use this right here, the third tool, because that represents between. So first we want to enter in the mean. So the mean in this case is 6.3. And the standard deviation is 1.5. Okay, so we enter the mean and standard deviation, and now that will be used in the functions that are already put in down here. And now we want to put in the between values. So x1 represents the lower value. So that represents the value right at that line right there on the left side of the shaded portion in red. And then x2 is the upper end of the red shaded portion. So that's 8, the value 8. So we have a normal distribution that is centered at 6.3. So the center of this distribution is 6.3. And then we have a standard deviation, the spread, the dispersion of 1.5. That's how spread out this normal distribution is. And we have a left bound of the red shaded portion of 3 and a right bound of 8. We want to find the area in between this. And we see that it's about 85.755, so forth, percentage. Or in decimal form, it's given 0.857 and so forth. So what we want to do is consider a group of 1,200 newborn babies, and we want to know how many would we expect. Well, we would expect this proportion of them, 85.75%. So what we would do to find this is we would just take, and we can do this in Google Sheets, equals 1,200 multiplied by this value above. So that is about 85.8%, 1,029. So since we want to know how many would we expect, we can go ahead and we would enter the answer rounded to a whole number because we're talking about how many. We can't have a decimal if we're talking about the quantity of babies, newborn babies. Okay, so that's how you use this tool. And in this case, we're wanting to know how many. We may actually be looking for a probability, and in that case, we would have stopped right here. And now, let's look at the next problem. How many would we expect to weigh less than 6? Less than is shaded to the left. So out of these three tools, it would be this one right here, the first one, shaded to the left, because we want to know how many would be less than some value. So again, green cell only, enter your data in the green cell. So our x value is 6, and the probability of being less than 6 is 0.42, and so forth. So less than 50% is below 6. And that should make sense since the center of this distribution, right in the center, is 6.3. We're to the left when we're at 6. So that value right there is 6. The center is 6.3. We're at 6, so that's less than half of the data values. It just happens to be that this line is pretty much right where we would expect 6 to be. So it's just a coincidence that that red portion looks pretty accurate for what we're looking at here for this problem. And now we want to figure out how many. Again, I'm not going to go ahead and do this, but I expect you to know how to do this at this point. we would multiply the 1200 by the probability here, and we would figure out how many would be less than 6. All right, let's look at problem 3. How many would you expect to weigh more than 5? More than is shaded to the right. Shaded to the right is more than some value. So in this case, we would use the second graph and the second tool under probability, and we would put 5 in. More than 5, that has a probability of about 80%. And it would make sense because we would have 5, and that's less than 6.3. So it would actually be over here somewhere. So we're shading well over half of the shaded portion. So yeah, 80.6% approximately. And then, of course, we would find how many if by multiplying by 1200. Lastly, how many would you expect to weigh between 6.3 and 10? And just like before, we would put in 6.3 and 10. And notice that I had this function here equals 1200 multiplied by whatever value is here. So since this changed, this also changed. So there we go. We found the value for 4. So this is how you'd use this tool if you're dealing with probability involving a normal distribution.